Hello and welcome. My name is Michael Bennett, and on behalf of the SwiftEye Medical Solutions Data Science team, it is my pleasure to kick off this presentation. Today, I will cover introductions and a short background of the virus. My colleagues will cover the business scope of the project timeline and deliverables, the data will be utilized, our approaches in regards to tackling the project, model overview and results. We also created dashboard prototype and mobile applications, which we will walk through. Then I will wrap things up with future recommendations and conclusion. Healthcare is an industry permanently aimed at future technologies. So who are we? We are SwiftEye Medical Solutions, a medical solution organization powered by modern artificial intelligence technology such as computer vision. Our mission is to drive preventative and diagnostic health methods into the future. Our team consists of 5 members. Again, I am Michael, and I lead and coordinate business analysis. We have Amkar Karkar, who is our primary developer, technical project manager, Tom Zhang, our medical expert, data consultant, Esma Ganesh, primary developer, data analyst, and Jalen Brown, our product developer, primary project manager. COVID-19, the coronavirus disease first detected in late 2019, has spread faster throughout the United States since last spring. It has led to high mortality and national health issues. It is a respiratory disease that can lead to acute respiratory distress syndrome, ARDS, and eventually to death. This condition can be diagnosed using RT-PCR techniques as the gold standard. It uses nasopharyngeal and throat swabs, but this approach requires specialist equipment and can take at least 24 hours to produce a result. It is not completely accurate and may require a second RT-PCR or a different test to confirm diagnosis.
Hello everyone, my name is Zhang, called by Tom. I have a medical background and now I'm working on a data science master program. So today my role is to introduce a few sections here, including business scope, project timeline, overview of the deliverables, and the data overview. There's a couple of target clients which do have an increasing demand of using computer vision to identify a COVID-19 or to diagnose COVID-19 based on X-ray, chest X-ray data or CT scan data. That is why we developed a project to help each target client and fit their clinical need. Our first target client is Stanford Healthcare Imaging Service. They committed to provide outstanding care, state-of-the-art technology, and offering Stanford world-renowned imaging service. Partnering with our company will allow each client to provide AI-driven imaging capabilities that is only available in limited clinical sites for COVID-19 diagnosis. Their service including X-ray, CT, MRI, and a list of different image services. Our second target client is UCLA Health Radiology Department. This department is led by a team of physicians, nursing, and technical staff, and scientists. Working with us is impacted to create a project called AI Imaging, and hopefully we could together deliver innovation and excellent radiological imaging service in patient care. Our third, but might not be the last target client, is California Hospital Medical Center. They offer a full line of diagnostic tools which allow performing at a high level of quality and safety for the patient. Working with us, and implementing the advanced machine learning technology in their workflow will help their opportunity to prepare and respond to spreading of COVID-19 better. So in terms of the reason why we develop a product, what is exactly is the clinical need from our target client? So the current approach to diagnose COVID-19 is called RT-PCR, which is also considered as a gold standard, using swabs and DNA testing with the sensitivity values ranging from 30% to 70%, which is not bad. But the weakness of RT-PCR is its technology requires special equipment, special staff, and take at least 24 hours to produce a result. And in many cases is not completely accurate and may require a second test, which takes additional time, cost, and may delay the treatment. Comparing to that, computer version working on chest CT scan or X-ray image has been reported to have sensitivity of 98 for CT and 69% for X-ray. People with suspicious COVID-19 symptoms need to know quickly whether they are infected or so they can receive proper treatment, self-isolation, and inform close contact. That's why the application of machine learning method on COVID-19 diagnosis has been facilitate the accurate and speedy diagnosis. The first primary client need of each product is to automatically recognize the chest image data, especially chest CT, chest X-ray scan. So we can see from here, panel A X-ray scan showing a normal subject. Panel B showing a COVID-19 patient. From C, D to E, F, G, they are all non-COVID-19 pneumonia. They're showing something similar, but most of them are not exactly same like the image we can see for COVID-19. That is the basic. That's why we believe computer vision can isolate, identify the features, the difference between normal and COVID-19 and non-COVID-19 pneumonia X-ray image. And then eventually machine learning computer vision can speedily tell the clinician which patient do have COVID-19, which patient do have pneumonia, but that is non-COVID-19. So that can help patient and help the clinician make decision immediately and take action immediately. Another secondary client need is to accurately detect lesion and measure the lesion during the disease course of COVID-19. Specifically, it is an increasing need from our client that is to help them determine the lung lesion status during COVID-19 course using chest X-ray imaging system and correlate these lesion status with patient demographic information, including age, sex, outcome, and family history, things like that. The picture here showing the lung lesion marked from chest X-ray that be assessed by senior doctors and now is expected to be detected by computer vision technology. Actually, from panel A, B, C, and D, they're all same image. The only difference, is you can see each image was labeled by computer vision by different box. So the fact is the effect of confidential score thresholds are different from A to D. A is the lowest, let's say 0.005. B, let's say 0.02. C, let's say 0.1, and D 0.2. So that's why the computer version will identify more lung lesions in panel A, but only one in D. And the category of the lesion is even more in panel A. That is how computer vision is supposed to work on identify and measure the lesion status on COVID-19 X-ray image system. So this project was started on late June. And after last week of June, we determined the scope. We identified the target client and determined the business scope of the project. Then the next week, we started to perform EDA and review the data and explore the data and determine and submitted our project goals. Later next week, we finalized our data and model and submitted our initial funding and summary. And then later we did further adjustment on our model and analysis. We also visualized our data dashboard and application. We also run a couple of client analysis. Yeah, so the final review was last week and submitted the final report. Each week we're doing final presentation. We did August from August 25 to the project end on August 30. This project is aimed to make two deliverables. The first one is analysis and analytical models. It is about machine learning model coupled with data analysis designed to make diagnosis and report on potential COVID-19 patients. The second deliverables is dashboard and web and mobile application. The dashboard and web application are designed for doctors for our target client directly. The mobile-based application is designed for the patient who are supposed to be the customers or the client of our client. So eventually it should be a functional product that makes interacting with about model easy and simple. Here it is an overview of the data we have in each project. In total, for the training dataset, we have more than 6,000 test scans in DICOM format, which later was pre-processed into other image data format and probably scaled down for better, computer performance. And all its data were de-identified to protect patient privacy. All image data were labeled by a panel of doctors, including 4 categories. That is what we see here, including typical, atypical, negative, and the intermediate. 4 different labels. On top of that, the file also have information including the bounding box in easy readable dictionary format. That is another second layer of the goal we have to identify for our client. Okay, on top of the testing dataset, we also have more than 1,000 images for testing data that will eventually be used to evaluate the performance of our model. Here, it is 4 image panels showing the average image display in each category, including typical, atypical, negative, and the intermediate test X-ray. For COVID-19, it seems typical COVID-19 involves peripheral distribution with bilateral lung involvement. And compared to that, native subject has very clear error in both lungs.
Hello, my name is Amkar, and I'm going to be walking you guys through some of the machine learning elements as well as the data processing that we did for this particular study. In order to understand what we did with the images here, we first have to understand the format of the images that we use and how we processed it. All of the images that were provided to us were provided in the DICOM image format. DICOM is a very standard image format used by medical professionals, particularly by the Society of Informatics and Imaging, as well as the Radiological Society of North America. DICOM consists of very high quality and high resolution images which are provided to us for each patient, similar to the example that you're seeing on your screen before you. This particular image shows an X-ray scan for a particular patient, what his or her lung scan would look like if they were passed through an X-ray. And these are the types of images that we are working with specifically in order to detect if there were any infections and what the bounding box regions should be. Now, a couple of things about the DICOM format. DICOM is a very standardized format. Again, like I mentioned, it's used by the medical community. But the key thing to keep in mind is this image size is about 3000 by 3000 pixels. What that means is you're going to get a very super high quality resolution in the image itself, as you can see from the example that we've provided. But this means that this is very, very difficult in order to scale for large deep learning models, because it means that your batch size and a lot of your training are going to be affected by it. Simply put, we don't need a large 3000 by 3000 pixel image quality. We can make do with a smaller image. So what we did is we basically were able to increase the image resolution, first starting from 256 by 256 pixels, and then using another variant of this, which was 512 by 512. And yes, as you can imagine, we were definitely able to improve the model performance by increasing the image resolution to capture the finer details that were present in the 512 by 512 images, which we would not have been able to capture if we used the 256 by 256 pixels. So there was some difference in the image resolution, but that definitely doesn't mean that we needed to use the full 3000 by 3000 pixel images. Now, I want to talk a little bit about two of the modeling techniques that we used in this particular project. In this case, we were using a model called YOLO V5. YOLO stands for You Only Look Once, and this is a model that is based off of what we call a single shot detector, so there was one stage detector. Okay, it basically means that it is a model that can basically make do both the bounding boxes as well as the image classification all in one step without necessarily doing multiple stages. So it is a one-stage detector, effectively, is the term we would call it. Now, this is basically a model that's provided to us by a company called Ultralytics. Ultralytics is an open source company that does research into vision and AI methods and has the potential to do a lot of things. Now, why is this model particularly helpful? Well, one, it's very fast and runs very, very well. Two, it's really good at extracting features and can automatically extract the important parts of the images for you. On the right-hand side, what you're seeing is a brief overview of what the YOLO V5 architecture looks like, and you'll see that it consists of different kinds of backbones, a neck, and actually a head. And this is the overall network architecture, which is commonly referred to as YOLO. I won't go much into the details here, but I will say that we are leveraging the state-of-the-art techniques, and we are leveraging the state-of-the-art technologies such as convolutions and other mathematical transforms, which have been worked and demonstrated to be very, very well in the field of images. So we are continuing to use some of the best in practice methods in order to test it out. So here's an example of what the faster RCNN model looks like. You take an image, let's say in this fictional example we're using 640 by 480, you'll pass it through to a pre-trained ResNet layer. The ResNet layer will then pass it through to a regional proposal network. Then you'll have an additional alignment between both fully connected layers as well as convolutional layers. And then it'll give you an actual mask, which will give you the actual output of where your bounding box was, as well as what categorization this is. I want to keep in mind that the ability to pool and use both fully connected layers as well as convolutional layers, which are known for processing images, and fully connected layers are traditionally what you might think of, processing numbers and text and categories. We're combining the best of breed approaches in order to give you the best prediction possible. So I want you guys to keep that in mind. Okay, Let's talk about the results that we achieved and what we did. So first, I mentioned before that faster RCNN is relatively fast, and we've seen a considerable speed up over some of the baseline methods. However, when we tested the model out, one of the things we quickly realized is that it just does not compare to how fast a YOLO is. So keep in mind that the YOLO V5 model that we tested was extremely fast, and it was way faster than even faster RCNN. But we still tested a few iterations of faster RCNN to do the performance comparison, and you'll see that later on in some of the dashboards that we share. However, I want to turn your attention to the YOLO V5 model, which was the predominant model that did very, very well. We tested 6 model iterations on the 512 image sizes and 3 on the 256 image size, so a total of 9. I'm going to concentrate on the 512 image size because that's where we saw a considerable, improvement in performance over 256, and those were really the candidate models that we were considering to be deployed in a radiological setting. Okay. Now, run 5, model 5, out of the 6 model iterations that we tested, was found to be the most promising. This was having a precision of about 0.5776 and a mean average precision at a threshold of 0.5 equal to about 0.4543. So how do I interpret this? Well, basically what that means is model 5 was above average in detecting images that had both atypical and indeterminate appearance, but not only that, but most of the time it was also able to capture at least half of the area where we saw that there was an infection, which means that when you see a bounding box in these images and you see exactly what the output looks like, the infection that you're going to be able to detect by the model covers at least 50% of it in over, close to 60% of the cases that we've seen. And this is a huge, improvement and a step up. The thing is in most of these images, radiologists are currently having to look at this manually, and they're having to go through and figure out where the infection could be. We've eliminated some of that challenge by helping you to understand where the bounding box could be. I'll talk very briefly about some of the hyperparameters and tuning that we did. We looked into things like the model tuning rate, how fast it trained, the learning rate, and adjusting those parameters. We didn't change the image quality such as hue, saturation, translation, and those things because we just weren't sure if that were going to have an effect on the way the images were. We wanted the model to be adapting to images that were slightly diagonal or were taken at somewhat of an angle, and we wanted the model to be robust and flexible enough to handle that. And so perhaps further studies and further exploration might have looked into how we could have done with saturation, translation, and hue. And finally, I'll touch very briefly on interpretability. Interpretability is a very key factor, and the point is we need to be able to tell radiologists and businessmen and anyone who's interested in this model why particular decisions were made and what parts of the image were used to make a particular decision. So I'm pleased to show that the image on the right hand side that you're seeing here is able to take each and every single step of the for each layer that was part of the YOLO model, and we can actually show you what part of the image was salient and had the most important factors, you might say, for making a decision. So you'll see in some of these images, you'll see yellow and blue and so forth. Those are basically different regions of intensity indicating which parts of the image played a key role for that. And the key is, again, we want to be able to discuss this with radiologists and businessmen alike to help people understand which parts of the model were being used to make a decision. So that's a little bit an overview as to how we achieved these models and what results were made using the machine learning techniques that we used here.
Hi everyone, my name is Esma Güneş and I am primary machine learning developer, and my role has been mostly balancing the connection between business, model development, and creating the dashboard to ensure technical and company success. Also, sometimes I have been supporting data analytics part as well. So let me start by saying what does this data actually mean? That answer is actually on our dashboard. So at the end of the day, we want to provide a view not only for the client, but for every single person that would be able to use this in the sense of insurance companies or hospitals. So currently we have built this for Stanford Healthcare Imaging Services. And the way we approached this was creating 3 different dashboards on Power BI. We have 3 views. Our first view is client view. And with the client view, We have overall, the first page is a client view, which displays general visuals with age, gender, and COVID results being added as a filter. And in our second view, we have a dashboard for the patient, basically as a SwiftEye chest X-ray classification tool will be already available at my SwiftEye based on both websites or mobile application. This tool will be accessible through cloud computing environment with just a few clicks, or it can be fully integrated in our client's radiology department workflow as well, a local solution for seamless interpretation and quick diagnosis. And of course, evolution of COVID-19 would be more visible. So in this view, basically, patient is allowed to access using their IDs to see the view what they got. And our third is the model performance. So this is the result page, which consists of the insights, visuals regarding the results done in the Python. It comprises of total runtime, precision, recall, and matrices for each run type. So I'm going to go ahead and continue to presentation on our Power BI. So you can see the live demo of our actual product. So as you can see, we are on our Power BI screen. In here, this is interactive dashboard, and let me start with going to client view. Okay, here we go. So over here, we have our first view. The KPIs we decided to use as the gender, male, female, or it could be unknown because they didn't give it. Age group, we decided to use age above 60 or the below in this case. And of course, COVID results, either negative or positive. And you can see from this left top side is the COVID positive cases across the dates. So we use the date as a filter here, and this is a demographic, basically general. What are the symptoms regarding that gives away if it is COVID positive or not, just to get the idea for the doctors or the insurance companies or any manager to go and see what's really happening. So basically, this is the general dashboard that gives all the general stats regarding the data set. This dashboard consists of total positive cases across the days, based on the days, as you can see, and actually month is you can see for September, November, and other months as well. The total population tested positive, population with effects such as sore throat, cough, and etc. is here the data we have. And then it also has visuals to display patients with shortness of breath, which you could see it here, with fever, cough, and other COVID symptoms. So necessary filters has been added to the dashboard, which gives user a highly interactive dashboard. Let me move on to our second dashboard, which is our patient view. If we click on here, it will take us there. So patient view. Patient view in this dashboard, the patient view dashboard gets patient's ID. And as you can see here, we have the list of the patient ID. We would like to make this more interactive, and the patient already enters their social security number. It's just going to pop up whatever information they have. So it displays general information about the patient, such as the age, gender, um, gender, type of the disease detected. In this case, is it pneumonia and COVID? And then in here, we could see it also displays the chances of the survival, chances of intubated, or chance of going to ICU based on the patient's age group, gender, disease, or detected. So this gives clear idea to the patient what are the chances and the risks that patient going to be ending in one of those cases. So in here, for this case, patient doesn't have a risk to be intubated, or in here there's 56, no 46, maybe ICU situation is possible. So, and furthermore, it displays the scan images before and after the detection of COVID. So this is currently not interactive. We are hoping to make it more interactive in our future work. So we are hoping as soon as patient enters their ID, there will be a screen X-ray, their own lung X-ray will pop up, and then it will also show the detected areas with our algorithm. So this is this patient view, and let me go to the last view, which is the result page. So in here, the dashboard consists of four graphs which all gives detailed insights regarding the results obtained from the Python models that we have created. So the foregraph represents the results for total runtime, precision, recall, and metrics for each of the runs in the model. The model also compares the RCNN results for both runs, precision, and recall as well. So in here, in our upper left screen, you could see all the models. We have 5 runs, and each run has taken almost 2.5 hours. In this case, this is constrained to work with. If we would upgrade the hardware, we would improve our performance in less time. So run first in our recall, as you can see, the run first is the best recall metrics we have got, and run 5 in our precision is the highest. So in this case, we prefer precision higher than recall. That would be further improvements will help determine the desired precision and recall. Acquiring client data will give access, acquiring the client that will allow us to get more data and maybe better performed results. So with all that, I would like to add our future work. We have been planning to create more, develop this dashboard more interactively. Like as I mentioned, in our patient view, we would like to really create more dynamic images. And with that, it needed to require more time and more data. That was the constraint. Thank you so much. I leave it to my next Michael. Thank you.
Hello everyone, my name is Jalen Brown. I am the project and product manager for SwiftEye, and I will be going through our mobile app concept designed for our clientele. The purpose for this product is to create an easy, simple, fast way to utilize our machine learning analytics models, as well as integrating the dashboard product that Esma so kindly went through previously. Mainly this app is a quick, easy way for either doctors or insurance companies to access the information our models are interpreting, as well as various details of the patients and cases that they're going through on a day-to-day basis. Looking at just the functionality of the app, the main aspects starting off are creating a easy home design to quickly carousel through patients that are going through the COVID evaluation process, having action buttons to quickly see what their status is in regards to COVID detection, and as well as having easy access to patient information. We will work with our client's tech team to integrate a safe and secure connection to their database and only access the information that's needed. So keeping contact or personal information confidential, relying mainly on patient IDs or maybe a first name, including a patient profile pic or even just an icon, depending upon our client's preferences, And then in regards to the details for our patient or for their patients, mainly looking at the reported symptoms, relative medical history, and any x-ray results. As we continue on with the functionality of the app, the COVID evaluation process has kind of three main stages. First, we will have a pop-up that will highlight what our model results are. So what the detection was for the specific x-ray, the type of COVID that was identified, as well as the highlighted areas of the x-ray scan. And for our client, they'll have the option of kind of reviewing the results of the model and even having their own manual interpretations of the results that they can provide, or simply just going straight to the patient's details and kind of analyzing the individual case itself. Along with that, the client will be able to carousel and scroll through all of the x-rays for any given day so they can kind of see the similarities, the different results that were gathered for certain x-rays, and even provide feedback as to what their professional opinion is on the results and if they requires kind of some further review. And lastly, having the option to determine certain actions for the COVID evaluation process. Looking at the toggles onto the right of this mobile wireframe, the client will be able to kind of denote whether or not the results make sense for this x-ray or this patient with the first toggle. Second toggle is being able to either close out this case if they've already met with the patient, already graded the diagnosis and treatment plan for this certain case, or three, creating a opportunity for them to dive into the results, kind of create their own interpretation that they feel that the model results weren't able to capture, and also provide feedback to us. As we continue to dive into the functionality of the app, I would like to kind of take a sidetrack to talk about the actual design and aesthetics of the app itself. We stuck with SwiftEye's brand of the simple blues with a bright white background to make things pop and simple to navigate the various features of the app. Very comforting to the eyes in regards to the different shades of the blues, and letting our clients know that this is a comfortable space for them to conduct their work and get productivity done. Along with that, we know that there are different preferences to how sharp certain colors may be to the client eye. So we've developed a dark mode that they can turn on if their lighting, scenery changed, or simply they prefer a softer glow from their screen or mobile device so that they can continue to work without any issues. Jumping back into the various functions of the app, we've kind of created some more client-specific features, such as a calendar for the doctor so they can see exactly how many cases they're dealing with on any given day and what type of results are popping up on a day-to-day basis, how many patients they're going to need to communicate with in regards to potential COVID cases, as well as being able to access their details previously on their profile details page. Along with that, we'll be able to provide them with time estimates as to how long this evaluation process will take, from accessing the x-ray scans to our models, analyzing the scans itself, and producing results on the COVID detection process. And from the end of that, we'll have a notification feature that they can turn on or off to let them know when this process has been completed, and they can access the patient's or client's details for that any given case. Now that we know what the functionality is of the app, we can kind of talk about how this is being integrated within the workplace. we know that there are different preferences in regards to devices, and so we've created the app in a way so that it could easily transfer over to a tablet device or even different Apple, Android platforms, Microsoft, Google platform, so that depending upon what our clients' needs are, we can communicate with them as to what the product will look like on their devices, collaborate with their tech team to implement that product, and safely deliver the app to their devices. Along with that, this will be a private distribution so that the public will not be able to access any of these products, and this will be only for our clientele. Along with that, we'll continue to ensure a safe, secure connection to any database, private information that they have, and anything that they access on the mobile app will be accessed on the tablet, and stemming over into what our web browser looks like. And as you can see here, the web browser view continues on with what our design is: simple, easy, comforting colors. I continue to use the word simple and easy because that sums up what our product is. We wanted to make sure that our clients could access the information, digest it, review results, communicate the information to the right people, and continue about their day-to-day lives and take action without having to worry about any tech issues of the product or difficulty navigating the product itself. With the web browser view as well, there will be secure access through via codes sent to your email, text message, phone call, whatever the preference is for our clientele, as well as being able to safely share information with their staff or even their patients. And with that, you can also send out or export PDF files that are static for the patient itself. And with this product concept, we're hoping to expand to a new product designed for their patients themselves so that they can access the information more hands-on, ask questions, gain some more information about what COVID is, and give them some comfort that the right healthcare professionals are taking care of their needs.
Our solutions utilize cloud computing. Our mobile app and dashboard web application are both provided as software as a service, whereas our local databases and servers are provided as a platform as a service. In conclusion, YOLO v5 yielded the best image classification and object detection results. These results will allow clients to make more informed decisions regarding COVID-19 infections. While we have achieved our goals, we believe we can fine-tune them further. There are several future recommendations we would like to make going forward. By increasing hardware available, we can decrease computational constraints to allow for more advanced models. We can increase the size of our training data sets to allow improved predictive performance, and we can launch our mobile and web application for private use. We will need to strategize a plan for expanding features for patient access to mobile web applications. Overall, we are proud of the product we have developed, and we hope you utilize it going forward.